Okay, it feels really weird setting it up like this and teaching something to an empty classroom, but I wanted to leave things around the room to support students as I am gone over the next 3 days. So for example, if you look right here, I have put up the two white books that are all about factored form, right? So the one on the left was when we were trying to graph a quadratic in factored form, and so we just used that factored form as was to get the roots. On the right hand side is when we learned how to go from standard form to factored form in order to solve a quadratic. Over here on this side, we have same thing from last week when we started in vertex form, found the vertex, found the roots, the y-intercepts to graph, and then right below it is today when we learned how to go from standard to vertex form, and there's an example there showing why I would not factor. But we ran into a radical there. We need to know how to simplify radicals. I created an example also for using the quadratic formula, and so that's the white book I'm going to use as explanation of how to simplify radicals. So I tried to keep things as linear as possible. It's more like your work is on the left over here, explanations on the right. But below here, I'm going to show how to simplify radicals. Now this one, we're not simplifying anything as far as I can see. Looking at 113, there are no factors of 113 that I can take the square root of. But let me show you what to do if you could in fact take the square root. So, or simplify that radical. So if I take something like the square root of 16, most of us know that we get a 4, right? That is because 4 squared is equal to 16. When we actively take the square root in the equation, we have to do the plus or minus. That's also why in that quadratic formula we have that plus or minus. However, let's say that I am looking at the square root of 48. Now, I don't want a decimal because that decimal is going to be irrational, or the decimal is never going to repeat, it's never going to terminate, it's an irrational number. So I want to rewrite this square root of 48 so that I can simplify it as much as possible. And so what I can do, and I'm going to show a couple of options. One, I can factor this into the square root of 16 times 3. All I've done is I've taken that 48 and rewrite it to the 16 times 3, and I'm about to show why, but notice that 16 is the perfect square that we saw earlier. There is a special property of radicals that actually ties into exponents. There's a property of exponents and powers because a radical is just a special type of power. I hope to get there and talk about that more heavily later this year in Algebra 2, but that is something that you discussed in Algebra 1. So from here, what I can do is I can actually just rewrite that one radical. I know a lot of teachers talk about pulling stuff out of that radical, but I'm not going to pull anything out. I'm just going to rewrite it. This is the same thing as the square root of 16 times the square root of 3. And now, instead of trying to pull things out and forgetting what I can pull out, I just take the square root of what I can. The square root of that 16 is simply 4. The 3 is not a perfect square, so it stays as the square root of 3. And that's how I'd simplify the square root of 48. And it's okay if you don't notice the 16 right away. You didn't have to. You just needed a factor that is a perfect square. So for example, if I look at 48, that's the same thing as 4 times 12. Now I need to continue this until I get all perfect squares. So I do need to notice that 12 also has a 4. And now, just like before, I'm going to rewrite this as my separate factors in the radicand. So one thing to be aware of, you'll hear me say this in class, the radical is the symbol, it's telling me which that I have a root. It's a square root because of what's called the index. It's not written there, but it's understood to be an index of 2, a second root. And then the thing underneath that radical is called the radicand. So because I have 3 factors in my radicand, I need 3 radicals that are being multiplied together. And just like before, square root of 4 now is 2, square root of 4 now is 2, square root of 3 is now the square root of 3. And now I simplify further, getting the same exact thing. So it's not a matter of pulling things out of that radical, it is a matter of taking the square root of the factors that you can take the square root of. Here's another example. So again, two examples, same thing. Let's say that I'm looking at the square root of 112, right? 112 is really close to that 113. And so I'm going to try to find my perfect squares. Start with the easiest perfect squares first. For example, 4. And if you take a calculator and you do 112 divided by 4, you're going to get 28. Let me check myself on that. Yep. And then I notice, hey, 28, so like I wouldn't have noticed that there was actually a 16 here, but I do notice, hey, that 28 also has a 4 inside of it, or a factor of 4. And so notice I didn't see the 16 this time, but it's still there. This actually works out exactly very similar to what we just had, so I'm going to do one more after this. But I separate this one radical into a radical for each factor. And square root of 4 is 2, square root of 4 is 2, square root of 7, 7 is not a perfect square, so I leave it there. 2 times 2 is 4, and I'm left with a radical 7. Alright, so let me think of another one. Yeah, that'll be good. Alright, so 150. Yep. Square root of 150. One thing we want to notice, again, we want to think about a perfect square. So 4 is not a factor of 150. 9 is not a factor of 150. 16, as far as I can think of, is not a factor of 150. But 25, that perfect square, is a factor of 150. And when I say 4, 9, 16, 25, I'm literally just doing 2 squared, 3 squared, 4 squared, 5 squared. And I notice that 150 is the same thing as 25 times 6. When I look at that 6, I don't have any factors of 6 that are perfect squares, so this is fine to stop at. I'm going to rewrite my radicand with 2 factors as 2 radicals, one for each factor, and the square root of 25 is 5. Notice all I'm doing when I simplify is I find every factor that I can that is a perfect square, separate my radical into those factors, or separate my radical into the number of factors that I have, and I take the square root of what I can take a square root of. Hopefully this is helpful for whoever needs it. And so there's the examples, the explanation will be on YouTube. And all you have to do is find whatever factors you can that are perfect squares so that you can take a square root.